Good luck.
Good morning, good afternoon, and good evening, everyone. I am Dr. Anjum Nazir Qureshi, working as Assistant Professor at Rajiv Gandhi College of Engineering, Research and Technology, Chandrapur. I'm author of a book, 10 Core Life Skills, Your Pathway to Success. I have worked for two international documentary films of UNICEF, and I'm also a life coach, parenting coach, and a career counselor. I'd first of all like to thank International Internship University for this wonderful opportunity to present my topic, green technology for sustainable development. So I will be just starting with the introduction of IIU. International Internship University is the leading virtual education system and global grant consideration, which is the most valuable, trusted worldwide, and well reputed in delivering innovative programs. Globally, it is a trusted name for quality training programs and committed to providing better and virtual education to the all young learners of the globe. In a short span of time, IIU has spread its wings in 195 countries and 6 continents under the strong leadership of its visionary founder, Mr. Piyush Pandit Sir, a committed and inspiring social activist, a passionate educationist from the last 2 decades, providing education to students from various social and cultural backgrounds. Green technology, as we know, sustainable technology or green technology, it deals with the short-term and long-term impact of things on the environment. It takes the form of recycling, renewable resources, health and safety issues, energy efficiency, and more. It gives the people hope to turn around pollution and the effects of climate change. It is easier to captivate clean energy from resources such as sun and water through these technologies and revolutionize the energy sector. It is meant as an alternative source of technology that reduces fossil fuels and demonstrates less damage to the human, animal, and plant health as well as damage to the world. The renewable energy sources can play an important role in helping to meet the basic energy needs through the use of modern technologies or the green technologies. The green technology policy to provide direction and motivation to continuously enjoy good quality and a good environment should be based on 4 pillars. First one, that is energy. Seek to attain energy independence and promote efficient utilization. Second is environment. Conserve and minimize the impact on the environment. Third, economy. Enhance the national economic development through the use of technology. And the fourth is social. That is improve the quality of life for all. The sustainable infrastructure. Infrastructure that delivers, we need to have infrastructure that delivers long-term economic, social, and environmental benefits. For that, we need to invest in sustainable infrastructure. It is more important now than ever before as the world is facing a climate crisis, a global economic slowdown, and the need to address inequalities that disproportionately affect the most vulnerable people. And the suitable infrastructure presents a tremendous opportunity for positive changes because 79% of the global greenhouse gas emissions are related to infrastructure. 4% of growth in global GDP by 2030 is possible with clean energy investments, and 92% of SDG targets are achievable through infrastructure investments. For achieving the global climate targets, It is critical to achieving global climate targets and SDGs and to a strong, resilient global economy. A major hindrance to decarbonizing infrastructure and achieving the SDGs is the shortfall of investment and sustainable infrastructure, which we call the Sustainable Infrastructure Investment Gap. Studies reveal that $2.6 trillion is required annually through 2030 to meet the Sustainable Development Goals and stay on a path to net zero by 2050. Reducing the gap could require more than 3 times the current level of investment in clean energy, and 70% of the spending is required in emerging markets and developing economies. Now, let's see some of the SDGs that are related to the environment. The SDG number 8, decent growth and decent work and economic growth. And that the point 8.4, it says that improve progressively through 2030 global resources efficiency in consumption and production and endeavor to decouple economic growth from environmental degradation in accordance with the EU framework of programs on sustainable consumption and production, with developed countries taking the lead. SDG number 11, which says make cities and human settlements inclusive, safe, resilient, and sustainable. And SDG number 12, which says ensure sustainable consumption and production patterns. Few more SDGs that talk related to environment are SDG number 13, which calls upon to take urgent action to combat climate change and its impacts. SDG number 14, which talks to conserve and sustainability use the oceans, seas, and marine resources for sustainable development. And SDG number 15, which says about to protect, restore, and promote sustainable use of terrestrial ecosystem, sustainably manage forests, combat desertification, and halt and prevent land degradation and halt biodiversity loss. So, as we can see here, because the world is facing the climate change, the global climate crisis, there is a need that we adopt green technology. Today, we'll be discussing some of the green technologies that can help us to uh, deal with the global climate crisis. So some of the physical green technologies that I will be discussing today are the solar photovoltaic, wind energy, biofuel, biogas, small hydropower, biomass, and the geothermal energy. Coming to the first one, solar photovoltaic. The solar technologies, they're actually dependent upon the sun energy, solar. It the amount of light that is striking the Earth surface in an hour and a half is enough to handle the entire world consumption for a full year. Solar technologies will convert the sunlight into electrical energy with the help of the solar panels or the photovoltaic panels to mirror and concentrate solar radiation. This energy can be used to generate electricity. It can be stored in battery or thermal storage. Solar energy technology doesn't end with electricity generation by PV or CSP system, and therefore the solar energy system should be integrated into home, business, and existing electrical grid with varying mixtures of traditional and other renewable energy sources. So the places like, especially like the place where I live, I know it has it is very hot throughout the year. So the places where the sun light or the sun solar energy, if you're receiving in a very large manner, so in such places we can easily switch to solar photovoltaic or the solar panel that we can be using the solar energy, which is a form of renewable energy and it doesn't end. The second form of green energy or the wind energy, non-renewable renewable sources of energy is the wind energy. Wind, it can be used to produce electricity by converting the kinetic energy of air and motion into electricity. In modern wind turbines, the wind rotates the rotor blades, which convert kinetic energy into rotational energy. And this rotational energy is transferred by a shaft switched to the generator, thereby producing electrical energy. The amount of power that can be harvested from wind depends upon the size of the turbine and length of its blades. The output is proportional to the dimensions of the rotor and to the cube of the wind speed. Wind power has grown rapidly since the year 2000, driven by the research and development, supportive policies, and falling costs. Global installed wind generation capacity, both onshore and offshore, has increased by a factor of 98 in the past 2 decades, jumping from 7.5 gigawatts in 1997 to 733 gigawatts in 2018, according to the International Renewable Energy Agency's data. The onshore wind capacity grew from 178 gigawatts in 2010 to 699 gigawatts in 2020, while offshore wind has grown proportionately more, but from a lower base from 3.1 gigawatt to 34.4 gigawatt in 2020. So the areas where they receive a good amount of wind energy should be looking for more research and development in the area of wind energy so that wind energy can be adopted as an alternative source of energy. And moreover, because it doesn't cause pollution as compared to the other fossil fuels that we are using. So yes, it can save the planet. So this is a small graph of the electricity generation trend, which covers the data from 2011 to 2020, and how the electricity generation has increased in electricity generation using wind energy has increased in the last decade. If we can see, yes, the onshore and the offshore, it has only increased for the last 10 years, and it is hoped to increase more. The third kind of green energy source that I would like to discuss is biofuel. Unlike other renewable energy sources, biomass can be converted directly into liquid fuel. This is called as biofuel to help meet transportation fuel needs. The two most common types of biofuels in use today are ethanol and biodiesel, both of which represent the first generation of biomass technology. Ethanol. This is a renewable fuel that can be made from various plant materials, collectively known as biomass. Ethanol is an alcohol used as blending agent with gasoline to increase octane and cut down carbon monoxide and other smog-causing emissions. Biodiesel is a liquid fuel produced from renewable sources such as new and used vegetable oil and animal fats and is a clear burning replacement for petroleum-based diesel fuel. Biodiesel is non-toxic and biodegradable and is produced by combining alcohol with vegetable oil, animal fat, or recycled cooking grease. The next kind of green energy that we can be using is the biogas. It is a renewable fuel that's produced when organic matter, such as wood or animal waste, is broken down by microorganisms in the absence of oxygen. This process is called anaerobic digestion. For this to take place, the waste material needs to be enclosed in an environment where there is no oxygen. The biological matter that is used to produce biogas will naturally decay anyway. So capturing the gases produced by this decay and it can be used as an energy source, it will cause less harm to the environment than allowing them to escape into the atmosphere. So, it can be also used to fuel the vehicles. If biogas is constant, it can be used as a vehicle fuel. It can be used as a replacement for the natural gas. So if biogas is cleaned up and upgraded to natural gas standards, it is then known as biomethane and can be used in a similar way to methane. This can be included for cooking and heating. And yes, biogasification in some of the areas in India, it is still prevalent, but even in this sector, I can say, though the people know that how useful biogas is, but sometimes the people are not paying attention to it. I will be discussing about this, why some of the technologies, the green technologies, though we know about them, why we are not paying so much attention to it. So the next one is the micro and small hydropower. Micro hydropower can be one of the most simple and consistent forms of renewable energy of your property. When we talk of the hydropower, the people start imagining about, very large dams that can be built on rivers. And for building the dam, then you will have to cut the trees, you will have to relocate the people and all. But this hydropower, this micro or the small hydropower, if we talk, it does not require, most of the time, it does not require this relocation or the cutting of the tree. Hydropower, though it is, very efficient, but sometimes we don't consider it as a good form because, as I said, that we are cutting of trees and relocating people is important. And the amount of for the classification of the hydropower, again, whether it's a micro, mini or small hydropower, the people in different countries they have given different types of classifications also. But still, let's discuss in general about the small hydropower or the micro hydropower, we could say. A micro hydropower system needs a turbine, a pump, a water wheel to transform the energy of flowing water into rotational energy, and it will be converted into electricity. So if you have a water flowing to your property, you might consider building a small hydropower system to generate electricity. Micro hydropower system. It will usually generate up to 100 kilowatts of electricity. But a 10 kilowatt micro hydropower system generally can provide enough power for a large home, a small resort, or a party farm. So this small hydropower systems, you can see that it can be used to power your houses, and sometimes if we just increase its capacity, might be for some small industries. Or now, what are we talking about the small hydropower or the micro hydropower? Because this has high efficiency, nearly 70 to 90%, and by far it is the best of all the technologies. It is a long-lasting and robust technology, and the systems can readily be engineered to last for 50 years or more. It is environmentally benign, and microhydro is in most cases run of river. In other ways, any dam or barrage is quite small, usually just wire, and little or no water is stored. Yes, because we can see the difference over here. Here we are not storing water as we are storing water in big dams. We require dams to construct a hydropower plant. So here there is no storing of water and not more of infrastructure is involved. And benefits of having small hydropower plants. There are no direct carbon dioxide emissions from these hydropower. Hydropower is the world's number one source of renewable energy. Small hydroscale has minimal visual impact on the surrounding environment. Hydro installations can have a useful life of over 100 years. Many such plants are in existence worldwide. A modern hydro turbine generator can convert over 90% of the energy in the available water into electricity. This is more efficient than any other form of generation. Let's discuss about one more green technology, that is the biomass. Biomass, I have discussed a part of this in the biofuels also. The biomass is organic, meaning that it is made of a material that comes from living organisms such as plants and animals. The most common biomass materials used for energy are plant, wood, and waste. The biomass can be burned by thermal conversion and it can be used for energy. Thermal conversion involves heating the biomass feedstock in order to burn, dehydrate, or stabilize it. Different types of energy are created through direct firing, co-firing, pyrolysis, gasification, and anaerobic decomposition. Now, before the biomass can be converted into fuel, it should be dried. And this chemical process is called as torrefaction. During torrefaction, biomass becomes dry, blackened material, and it is then compressed into briquettes. Most briquettes aren't burned directly. The steam produced during the firing process powers a turbine, which turns a generator and it will produce electricity. Then one more process that is pyrolysis. During pyrolysis, biomass is heated to 200 degrees to 300 degrees centigrade without the presence of oxygen. This keeps it from combusting and causes the biomass to be chemically altered. During the gasification process, a biomass feedstock, usually NSW, is heated to more than 700 degrees Celsius with a controlled amount of oxygen. The molecules break down and produce syngas and flux. The anaerobic decomposition is the process where the microorganisms, usually the bacteria, will break down material in the absence of oxygen. In an anaerobic environment, biomass retains and produces methane, which is a valuable energy source, and this methane can replace the fossil fuel. Now let's see the effect of biomass on the environment. It is an integral part of the Earth's carbon cycle. The carbon in fossil fuels has been sequestered for millions of years. So when the fossil fuels are extracted and burned for energy, their sequestered carbon is released into the atmosphere. The fossil fuels do not reabsorb carbon. But on the other hand, if we talk about the biomass, it comes recently from the living organisms. The carbon in biomass can continue to be exchanged in the carbon cycle. And in order to effectively allow Earth to continue the carbon cycle process, however, the biomass materials such as plants and forests have to be sustainably sourced. Coming to the next form of green energy, that is geothermal energy. Geothermal energy is the heat energy from the Earth. Note that geo means Earth and thermal means heat. Geothermal resources are reservoirs of hot water that exist or are human-made at varying temperatures and depths below the Earth's surface. Wells ranging from few feet to several miles can be drilled into underground reservoirs to tap steam and very hot water that can be brought to the surface for use in a variety of applications, including electricity, generation, direct use, and heating and cooling. In the United States, most geothermal reservoirs are in developing states. The benefits of the geothermal energy. Firstly, it is a renewable form of energy. The heat flowing from Earth's interior is continually replenished by the decay of naturally occurring radioactive elements and will remain available for billions of years. The second is the base load. Geothermal power plants produce electricity consistently and can run essentially 24 hours per day or 7 days per week, regardless of the weather conditions. The third one is domestic. Geothermal resources can be harnessed for power production without importing fuel. Fourth one is the small footprint. Geothermal power plants are compact. They use less land per gigawatt hour than coal, wind, and solar power stations. The fifth and the most important, it is a clean energy. Modern closed-loop geothermal power plants emit no greenhouse gases and have life cycle emissions 4 times lower than solar-based photovoltaic cells and 6 to 20 times lower than the natural gas. Geothermal power plants will consume less water on average over the lifetime energy output than most conventional electricity generation technologies. Now, some of the criteria that will help in the selection of green technology. The first one, it is the ability of the technological device to stand alone for doing the required job. The second, people's realization that technological device can elevate the user's social status as well as meet a basic human need. Then, third one is careful assessment of the technology that is based on group approach and becomes more system dependent. The next one is the affordability of the technology. Yes, we have to, whenever we talk of technology, affordability, it really becomes a very big factor because though we are talking about the renewable energy sources and its usage, but still some of the technologies like the solar and the wind energy, especially it requires a very big installation cost. Though it has zero maintenance afterwards, but the installation cost is more. So in that case, sometimes it becomes difficult for the people to go or for adopt this particular technology. The next one is we have to understand the type of risk. Yes, sometimes there can be internal, sometimes there can be external risk. So we also need to understand the type of risk because any kind of technology that we want to adopt it cannot be we cannot say any technology is perfect. There will be some kind of pros, some kinds of cons related with each technology. There will be some kind of risk, so we have to understand the risk. Well, having a risk-free technology is not possible, but we should be having more research, more R&D work, so that this risk can be minimized. Then, the second thing, the evolutionary capacity of technology, because we know that the when we are having a technology, we can be say we should be able to know how that technology can be developed because we are going to progress and every day new changes are being rising up in the technological field, in the technical field. New technologies are coming one after the other. So we need to know how this particular technology can be improved further so that we can be getting better, we can be building a better application. Because nowadays we can see that the solar panels are being even combined with the IoT modules where solar panels are used to power the IoT modules. Like if you see the applications like the waste management applications. So yes, there are IoT applications which are using solar panels to power the battery. So we should be thinking of how these green technologies can be combined with the existing technologies, how they can be combined with the emerging technologies like the IoT or the AI, how it can be used. So that especially the battery storage, because this especially the IoT technology, if we talk about, so there we are working on batteries. So yes, if we can be using any of these technologies like this, especially the solar panels to power the batteries, so yes, we can be doing it. So there is a need that we increase more awareness about these technologies and help the people to adapt it. So here, some of the recommendations. First one, green technologies are not yet price competitive with fossil fuel technologies. The government must help in cutting edge clean technologies and create the framework conditions that enable renewable energy companies to bring their products to the market. The second is intensified dialogue on the national green policies. There is a need to extend public procurement and lead the way by cutting taxes on green products. Then the third is harmonize green technology standards, course, and contractual principles. Fourth one is we have to create best practices experts, international standards on green technology. Then the fifth is improve the knowledge sharing ability of multi-industry, multi-technology, clean tech representatives. And the sixth one is open and sustain the markets for green technologies to better trade policy. These are a few points that are really very important that can help in the adoption of green technologies because we know that the whole world, the whole globe is suffering from the climate change and there might be every use or every need cannot be satisfied sometimes using this technology. But looking at the benefits, we need to generate more awareness in the people. We need to come up with new policies so that the cost of installation, the cost of usage of this technology can come down and more people can adopt this technology. And we can be using more of research work on this area so that we come up with products that are affordable to the people. And this needs to be discussed at the global level, as we have seen in the earlier slide, because many of our LCDs, they are directly or indirectly talking about the climate changes and how the energies, the different kinds of technologies can play a great role and become bringing a sustainable development. So we can conclude that if we adopt this green technology, the world will be sustainability led and the environment will be clean and safer for all. Sustainable development is the development that meets the of the present without comprising the ability of future generations to meet their own needs. Sustainable development that is respectful of the social equity and environmental healthiness may occur only when it gets stronger international awareness and large-scale changes in the tendencies in production and consumption patterns. So yes, with this we can say that the fossil fuels that we are having, we should bringing up methods where because like green technology should be adopted because the fossil fuels that we have or the non-renewable energy sources that we have, we know that if we don't use it properly, it is going to end someday. But this kind of renewable energy sources like the solar energy, wind energy, it is something which are not going to get lessened. Like if we take out coal for some purpose, the coal reserves will end. But the sun energy will be continuously keep on getting the solar energy. And one more thing that I would like to state that the different clean energies that I have just discussed, like the solar energy, wind energy, geothermal energy, small hydropower plants, biofuels. So we can see that this can be used everywhere. These technologies that I have just discussed, and like most of you may be knowing, that we have to look at which particular technology can be used in our area, can be used in the place where we live, and according to that, we should try to adopt this technology. So thank you everyone. Thank you for your patient listening. And yes, these are some of the references that I have used. So thank you once again, International Institute University, Piyush Pandit sir, Vidya ma'am, and Inga ma'am for your cooperation and giving me an opportunity to share my knowledge about green technologies to assist. So thank you.